in this session, what Donna and I try to do is share our experiences. And so I will start, and then Donna will share her, be the counterpart. So the goal of both of our presentation is how to help you share with you as to what we have learned in how to make the collaborations with researchers in other disciplines more synergistic and more productive and more enjoyable. So in terms of what experiences have I had? So far, if I counted correctly, I've been part of about 35 grants from NIH, NSF, and IARPA. On these grants, I have worked with about 50 investigators and 100 plus of their students and postdocs spread across 20 institutions. And these collaborations have spanned computer science, electrical engineering, biomedical, statistics, psychology, physiology, medicine, dentistry, public health, and a few more. And across all of these experiences, you would expect, I've had my fair share of both failures that I've been trying to learn from, and successes that I cherish. And I would not claim to have found the best approach that works with everyone. So I'm still learning, still trying to refine my approach in how I interact with and how I work with my health researchers. But nevertheless, it has been an amazing experience for me. Over this past 15 years, I've grown so much in learning a great deal from amazing colleagues, and they are world-leading experts about health, physiology, cardiology, psychology, behavior, wellness. And all of this learning is not to say that I can stand in their shoes. All of this learning is to say that I know more and more of the words and what they mean when they use those words, and can derive. And they have helped me find new research problems in computing, which again, and these problems are then informed and inspired by health needs. And when we publish, then that shows up. And that way, others in the health community, they also, others in the computing community, they also get to benefit from those experiences because they show up in both presentations that we make at our meetings of computer scientists, as well as in the papers that we write. And so these collaborations have helped us envision the next generation of tools or devices that should be developed that have not seen the light of the day yet. And of course, collaborating with them increases the chance of funding, whether it is NSF or NIH. It increases the pool of funding that you will have access to. I'm right now trying to speak to those who come from computer science or technology background. And I say it's a rewarding experience because all of us in the research community, we like to have a high societal impact. And if dollars, our salary is what we are after, we wouldn't be in academia. We are in academia because we want to help the next generation grow, and we really want to have a high societal impact. And so working with them significantly increases that chance to have a high societal impact and have that connection. So that has been my experiences, and I have a great deal of regard for them. Now, next, what I'm going to cover is if you go seek out a computer science professor or electrical engineering professor, or a professor from engineering school in general, what is it that I wish or they wish their health collaborators knew about them? That's what I will cover. And when Donna speaks, she will say what those computer science professors or engineering school professors knew about their health research counterparts when they go seek them out or when they collaborate with them, right? So I will start by saying that if the technology you are looking for is available commercially, can be developed or served by an established company, or can be implemented by hiring a software engineer, then then those are the, so you should not reach out a computer science professor for. Computer science professors will not be able to give you any of those services, nor it is what excites them. So what is it that they do then, right? If they can't give you the mature technology, if they can't implement the app idea you have, I mean, why do they exist even, right? So, so that's what I'm trying to tell you as to who is a computer science professor. I mean, and this applies to electrical engineering or biomedical engineering. They are world-renowned experts in their respective fields. If they were working in industry, they would be CTOs, even CEOs or VPs or distinguished scientists, and their salary would be astronomical, as are of their students when they graduate. Okay? Same goes for the grad students. The grad students are not a cheaper version of software engineers. These grad students are one of the brightest young minds who chose not to join industry and come to grad school to get deeper knowledge, because they are, and many of them have significant industry experience. So why both of these are choosing to live a lot poorer life than they rightfully have earned with their education and qualification and knowledge? It's because they are researchers, just like you are in the health side. They love to publish. They love to advance the science in their respective domains, and that is what drives them. Okay? Many of them, because they are in engineering schools, they have 9 months salary that is already covered. That means they don't have to get grants to cover their salary. The remaining summer months that can be covered by NSF grants they can get. So they have many options in terms of if they need funding. So what I'm again trying to say is that funding is not what drives them. What drives them is what I was covering on the previous slide, to have a high societal impact, get to learn from their multidisciplinary collaborators. So if you work with them, what you get from them, again, that's not something which is comparable to what you get from industry. In what sense? So they develop prototypes, or their students write code. And the purpose is not to release as a product for use by consumers. The purpose actually is to show feasibility of the new ideas that they have come up with in computer science publications. That is the purpose. Okay. So from that sense, it's not really meant for others to use. It requires a lot of babysitting. These first prototypes anywhere, even in industry, they barely work. They have more bugs than they have features, right? So they are no match with any commercial products in terms of aesthetics, stability, durability, or documentation. If you want to think, have a commercial version of it, think about iPhone or Fitbit version 0.01. Think about what these products look like. iPhone was launched in 2007. So think about what they look like in 2005 or 2004, when they were just envisioning that product and they had put together a version, right? The first prototype that was used for internal tests, or developed by a solo engineer in their part-time, like 20% time of Google. So that's what they are developing. So then why should you even bother, right? But many times we researchers get excited about being the first one to do something, right? And so as a health researchers, if you work with these computer science professors, you have an opportunity to become a co-inventor. Many of these things that are first developed in academia, some of them go on to become a blockbuster products tomorrow, right? Qualcomm's chips being example, NVIDIA's a graphics card being another example, VMware being another example, Google's search engine being other examples. So there are many examples of things that were developed in academia, or the Roomba, the iRobots being other examples. So many of these that are developed in academia, they go on to become blockbuster products. And if you work with them, you have an opportunity not only to use those products, but be part of that journey, be part of that creation. So, and using that, you can make unprecedented new advances in your respective domains that wouldn't be possible otherwise. So those are the right reasons to work with a computer science professor. But if you choose to do so, you'll need plenty of patience, tolerance, and flexibility, because what you envisioned, you may not get exactly that, right? Because it's a moving process, and when you see it, because there are first prototypes, you'll see so many opportunities for improvement, so many things that can improve, right? And because when you have a direct line to the inventors, both the graduate student and the faculty, you will feel like, okay, how about we change this? How about we improve this? right? And so it's very easy to get caught up in that cycle or in the temptation of issuing never-ending feature requests. And know that each such feature request both increases the cost, time, effort, and introduces more bugs than it introduces features. So you have, I mean, what you will end up with deploying in your participants will be even harder to use. So so then what's the solution? So my advice is there is a version that is covered in their respective computer science publication that has a specific citation. Stick to just using those features that were covered in the publication. There are, again, you will see lots of opportunities to improve, but unless those improvements excite the grad students and the faculty because it can lead to another paper, it's not worth it. It's not worth their time, and then it becomes a burden for them. If it becomes a burden, then you are not going to enjoy that collaborative relationship yourself. So in terms of, we establish collaboration because we want to contribute to each other's success. We want to make, the sum be greater than the whole be greater than the sum of the parts. So some things that have served me well is being clear about who is going to lead which kinds of publication. So, if from our lab, we never lead publications that is health related, meaning that those that go in health related journals. And so whatever we publish, we always publish in, lead publications in computing venues and support our collaborators in their publication in health related venues. That keeps each territory unencumbered by the other side and will not create any adversities. Next is publication opportunities at different data collection stages. In health, it used to be the case, and many times it is the case, that you wait till you have the data collection completed, curated, and finalized before you submit to the top tier journals. And because each of those publications, they can have significant impact on public policy or health practice, it's important that you be authoritative. But in computer science, the focus is on ideas, because ideas is what gets adopted, both in industry as well as others who build upon it. And so for their purpose, they don't need the full data set. They don't need the full curated data set. And so, so holding their publication until the data set is complete is going to be counterproductive for the team. Then there are some, in some cases, perhaps discipline specific, you may feel like, okay, I'm going to develop an approach that, okay, data set can only be requested by such and such, data set can only be used by such and such process. If for your collaborators, the data set becomes hard to use, then it's going to hurt the entire team. And keep in mind the data set, if you are using the technology that was developed by your computer science collaborators, then the data set has a shared ownership. Even though you may be the PI on record on the IRB, or the data set may be collected at your site, the effort investment has been equally hard on the other side too. So therefore, know that it is a shared ownership of the data and should not try to assert rights. So it's more like giving the ownership rather than taking the ownership. And so why I'm saying that obstructing publications with rules, by citing the discipline specific norms that, okay, no, you can publish only if you have approval from this, then you have approval for that, is that, computer scientists, they move really fast because that's the nature of the field. Publications happen very, very quickly because the power is in the ideas. If they see that a lot of time is being spent in accessing the data, for proving the feasibility or power of their ideas, they don't necessarily have to use this data set, even though they spent a lot of effort in helping you collect it. If they find it hard, they will use some other publicly available data set and they will proceed. So why is it a self-inflicted harm? The reason is that if those students, they did not use your data set, then guess what? Your data sets will not be curated. You won't have anybody else who can work and clean and make sense out of your data. So you'll be left with your data but nobody else to help you make better sense out of it. So therefore, facilitate publications. It's great to get the mind share of those amazing students that come to your computer science collaborators, and be part of their journey, be part of their career growth, because that will come to benefit you. All right, so in general, the approach should be to reduce the burden on each side as much as you are able to. Like from the computer science side, make your technology or your prototype such that your health collaborators can use it more easily. They have less burden in deploying the technology. And from the health researcher side, you reduce the burden on your computer science collaborators to make sure that they have easy access and quick access to the data at whichever stage that their publication fits. And that way, you'll maximize the utility of this collaboration for each party and be part of each other's success, right? So with that, I'll end my presentation. If I think we have some time, we can go through some questions, and then Donna, would you like the format that you go first and then we handle the questions?
Oh no, let's let people ask you questions now, that otherwise they'll forget if they're anything like me.
Yeah, I try to keep the presentation within time so that there is some time for questions.
That was, by the way, Santosh, that was great.
Thank you.
It's hard to see questions if you keep your slide up.
Okay.
I have a question that is related to publications, and is the flipped situation. So a statistician working with the medical doctor or the scientist who actually collected the data. And basically the situation where at the beginning, the publication, when at the decision of the publication authorship, it's always natural that the person who collects the data should definitively be part of the publication. That's basically what has been my experience, that even if I publish in a statistics or a biostatistics journal, for me it's very natural to include the physician or the other scientist who has collected the data that I cleaned and analyzed and so on. One question that I had is whether you think, that's fine. And for me, it's been usual practice, and whether there is a distinction if instead I decided to go in a machine learning or computer science type of publication, which I see this happening, to also target that audience for my work. And the second aspect is how to face the fact that most of the time, even if I go to these type of avenues, the physician I'm working with would like to be last author in the publication, where the work has been led by me, and maybe I trained even postdocs or other students who need to be first authors. So I really would like to give them the first authorship, but also if I'm early in this career, for me it's important to either be first or last. That's my understanding. And how can I navigate this communication, and what is the best strategy here? Because I really want everyone to get the best out of this work together, and I want to really acknowledge that without the whole team and enrollee participants and collecting the data, my work would not be possible.
This is a great question. So now let me first say that you have a specific problem right now, but what you are speaking about is a problem that is there for many others who don't have this floor today, and others who will have this problem in future. So whatever I'm going to say, or what we are doing in this institute, is trying to help establish a culture which may not come directly to help you today, but hopefully it will help others who get into your shoes tomorrow. Okay. So that's where the culture we're hoping to help establish is, think about what you can do to help others. And two, as I was saying, giving the right of way, not taking the right of way. So here that applies to the authorship. So if you are doing a multidisciplinary work, then being clear right upfront as to which kinds of publications will be led by which teams. Sometimes people get confused or get anxious about, oh, okay, if such and such group publishes this on this data set, then I won't be able to publish. And that is not true in my opinion and in my experience. Any publication in computer science or in statistics is quite different than a publication in a health discipline, because what's valued in terms of contribution are quite different. And so giving each other that space, think of it like a pie, and trying to grab as much as possible out of that pie versus expanding the pie. So the team always has a lot more benefit if you do everything possible to expand the pie. In the case of publication, what does it mean to expand the pie? It means that if I do something that will make the career of my collaborator, that will increase their reputation in their community and will keep them happy, it's all going to come back to give me much greater returns tomorrow than with the current pie that I have, meaning this one grant that I have, I maximize how much credit that I can get out of it. Because it's the impression that your collaborators carry out of this collaboration will determine not only whether these current collaborators work with you again, but also many more who they get to talk to, because word does get out in the community. And tomorrow, if you are realizing, I wrote to 5 people and why is everybody saying that they are busy, right? Nobody will come and tell you as to why this happened, but it all emanates from your action today. So that's what I mean by expanding the pie. What you want is, for your collaboration, what impression somebody else carries out of it. And that's what you should focus on maximizing. So in terms of what is the right approach? Of course, the right approach is any statistics, a paper published in statistics, the lead faculty should be the last author. They should have the ownership of that publication, both in terms of first authorship and last authorship. Anything in the health discipline, the health collaborator or whose students or postdocs or fellow are leading that publication, they should have the first and last authors. And so it's important to maximize the long-term gain, and long-term gain comes by contributing to the success of your collaborators.
Thank you.
Donna, you want to take over? So we are on time.
Yep, here I go. And while I'm pulling up my slides, I just want to say you can also model behavior, like what Santosh is saying about what